So today we're going to be looking at the graphs of sine and cosine, and just like anything else that we have graphed in this class, our first objective is going to be able to... So today we're looking at the graphs of sine and cosine, and just like anything else that we've graphed in this class, our first objective is going to be to figure out the general shape of each one of them, the general characteristics, how they behave, and then we're going to go into how could we use that general shape to possibly shift something up, down, left, right, or if we have something steeper or less steep, what does that look like for these functions? So you may remember these from Honors Algebra 3, and hopefully you do remember the general shapes of them, but I would go ahead and listen to this part because it may be something that you just accepted and didn't quite understand, and it always helps to be exposed to an idea more than once. So if we're looking at sine of x, first of all, what we're plugging into this is an angle. If we're finding sine of something, we're finding sine of an angle. So I want to put things on my graph for my x's that are angles I would actually plug into sine. And we're going to use radians for this. So if I'm plugging in angles in radians, I'm not going to plug in something that's not on the unit circle that I don't actually know the value of. I'm going to plug in things that I actually know. So pi is a really easy one to plug in. 2 pi is a really easy one. If I want to put in anything in between, we could put in pi over 2, 3 pi over 2. And we're just going to stick with those for today. That's really all we need to figure out the general shape, and then we can kind of think through what's happening in between those values to get a better picture for our shape. But when we're plugging things in here, so at 0, if we're finding sine of 0, remember on our unit circle that if we're at 0, we're at the point 1, 0, and that y value is the sine of that. So sine of 0 is 0. If we're looking at the sine of pi over 2, now we're up here. So we've got the point 0, 1. Again, our y value is sine, so now we've got a value at 1, so it's going to jump. That's our value at 1. If we're at pi, sine of pi is going to be 0 again. Three pi over 2. Now we're at negative 1 for sine. Give myself a negative 1 here. And then when we're back at 2 pi, now we're back at 0. So both of these functions are what we call cyclical, because after we get back to the 2 pi or 360 degrees, it's going to do the same thing again. So what happens with these is that once we have one cycle of sine, it's just going to repeat the same thing over and over for the rest of the graph. It does have a domain of negative infinity to infinity, so it's going to go in both directions. So if I fill this in a little bit, and I can kind of think through the fact that sine is going to be positive in the first and second quadrant. So if I'm filling this in, it's going to be positive all through there, and that makes sense. And then it's going to become negative for the third and the fourth quadrant. And then that's where it starts over. And typically if we're graphing something just to get a sketch of it, we're going to graph maybe one or two cycles is enough to get a good picture of what we're talking about. It is going to be the same thing in the other direction, by the way. So if we did go a negative pi over 2, a negative pi in this direction, a negative pi over 2 is going to be like 3 pi over 2. So it would be a negative 1. And then our negative pi is going to be like pi, so it's going to be back at 0. So if we went this direction, and this is just this end piece that it's going to keep repeating, it'll have that same da-da-da-da. Okay, so there's sine. Cosine will be similar as far as the approach, so I would go ahead and put in those same values for x that we had before, our pi over 2, pi, 3 pi over 2, and 2 pi. If you want to go in the opposite direction like we did last time, you can put in that negative pi over 2 and negative pi, just to kind of see what it looks like going the other direction. I just got the marker all over my hand. Okay, but then when we start to plug in these values, now we're looking at the x for each one of these. So at 0, my x value is 1, so cosine is going to start up at 1. For pi over 2, my x value is 0 on the x-axis. For pi, my x value is -1. For 3 pi over 2, my x value is 0. And then back at the beginning, 2 pi or 0 is going to be 1 again. So cosine starts up, and then it goes down and back up. And this is one cycle of cosine, but same thing as with sine. If we kept going with this, it's just going to make that same U shape over and over. If we go the other direction, we're going to have 0 for our negative pi over 2 or 3 pi over 2, and then a -1 for negative pi or pi. So it's just going to be that right side of that one cycle, and it would keep doing the U shape as well. So now that we know the general shape of sine and cosine, let's talk about how they can be shifted, manipulated for something that is a little bit more complicated. Now, trig functions in general can be very challenging to graph. We're going to try to keep this as simple as we can, but it does have more elements to it than most of the things that we have graphed so far, probably aside from rationals. Rationals had a lot going on. Okay, so we're going to start with D here, and these are all just variables to tell you that if I have added some number out here, that first of all, we're going to call D the midline, because this is that line that we're going to have exactly as much function above it as we have below it. So if we're looking at like the parent function for sine, the midline is going to be at y equals 0, because at that midline we go up 1, we go down 1, but it is the middle of the range, basically. And the way that we find the midline is by taking the min and the max and finding the average of them. So we're taking the average of min and max, which makes sense. For our parent function, our max is 1, our min is -1, so we're just saying 1 plus a -1 divided by 2 is just going to be 0. So that's why our midline ends up being at 0. Next, we're going to talk about a. So this is that number out front that we're multiplying the whole function by. In other functions that we've dealt with, this is that number that makes it steeper or less steep, and it's really going to do the same thing, but we're going to treat it a little differently. It is called the amplitude. And this is the distance from the midline to the max or the midline to the min. So distance from, I'm just going to say mid to max or mid to min. So if we're talking about that parent function, since our midline was at 0, the distance from 0 to the max is 1, and the distance from the midline to the min is 1. This will be the same no matter what. So your midline is exactly in the middle. So that should mean that your distance from the middle to the top or the middle to the bottom is the exact same. So if for some reason, say we're multiplying by like 3 out here, that would mean that we probably still have the midline. If that's still 0, the midline would still be at 0, but we would go up to a +3 and then down to a -3. Then we've got our C value, which we should recognize that C value, since it's with the X, that is our horizontal shift, and it is going to do the opposite of what we would think, just like normal. When it comes to horizontal shift, we always just pray that it's going to be something really normal to shift it by, so like pi over 2, something like that. It can get very complicated if we shift it something kind of strange. If we shift it like 1 radian, that's going to be very challenging to deal with rather than something that's on the unit circle. And then our last variable that we've got here is b, and it is the frequency. And this is probably the most challenging part to deal with, because this deals with how quickly our cycle is going to... And this one's probably the most challenging because it deals with how many cycles are going to occur in that 2 pi. So this is how many cycles occur for 0 to 2 pi. Okay, so frequency, how frequent are those cycles in the 0 to 2 pi, which is the normal length of one cycle. So something that we kind of have to add in here, it's not one of the variables that we're dealing with, and that is the period, which is the length of one cycle. So in our parent function, the period would be 2 pi, because typically one cycle of sine or cosine is 2 pi. And these guys go hand in hand. So when you're trying to figure out the period or the frequency, vice versa, typically we know one of them and we're trying to figure out the other one. So if we're trying to figure out the frequency of something, then I'm going to take 2 pi and divide by the period, because say my period is pi, that means that it's much shorter than it should be. So if I'm saying 2 pi divided by pi, it's going to tell me that 2 of them are going to occur in that 2 pi cycle. If I'm going the other way around, to figure out the length of a cycle, I'm going to take 2 pi and divide by the frequency. Because again, if I had 2 of those cycles happening in 2 pi, I could take 2 pi and divide by 2 and figure out that the period is pi. So either way, if I have the frequency and I'm trying to figure out the period, I'm going to take 2 pi and divide by f. If I have the period, I'm trying to find the frequency, I'm going to take 2 pi and divide by p. So for each of these examples, we're going to decide what parts we have here, because we're not always going to have the midline, amplitude, horizontal shift, and a frequency difference from the parent function. Hopefully we don't have all 4 of those things. So first we want to identify what is going to be different about our function versus the parent function, and then we're going to go ahead and attempt to graph it. So looking at example 1, I first might notice that I've got a 3 out front, and then I also have a 2 in there. So maybe just identifying any numbers that aren't just that sine of x. So any numbers we've got in here are going to affect it somehow. The 3 on the outside, since I'm multiplying by 3, that is my amplitude. And remember that amplitude tells us that my function is now going to be going up 3 and down 3 from whatever the midline is. I didn't add anything or subtract anything to the function, so my midline is still at 0 where it normally is. So it is going to go up 3 and down 3. My 2 is going to help me figure out my period here. My frequency is what the 2 tells me. So I've got a frequency of 2. But in order to graph it, that doesn't always help me necessarily in graphing a cycle of this. So if I know that I have 2 of them within 2 pi, I can kind of guess at that, because if I've got 2 of them, that means that one of them is going to be pi in length. But I do know that my period is going to be 2 pi over the frequency, so 2 pi over 2, which is pi. So that kind of helps me know that the length of one cycle is going to be pi. I'm going to be looking at that parent function, so starting at 0, where my pi over 2 typically is where I'm up to the top here, but I'm going to go through a whole cycle from 0 to pi. So that means that this is where I'm back at 0. For sine, in the middle, I'm also at 0, so that means I must be up at 3 at pi over 4, and then I'm down at -3, halfway in between the pi over 2 and pi. So here is one cycle of this. And we're really just going to focus on one cycle, but I could keep going and go up to +3 again, and then I'm going to be back at 0 at 2 pi. So for our next example, you can tell with my graph already that I've kind of thought through this is going to be longer than normal. But again, identifying those numbers that are different. We are dealing with cosine this time, but our 2 is that amplitude. So it's going to be going up 2 and down 2. Again, no midline change this time, so it is going to be going up to 2 and down to -2. And then we've got that x over 2, which is really just 1/2 times x. So that means that my frequency this time is 1/2. So that should tell me that my graph is going to be stretched from that parent function, because instead of having one cycle from 0 to 2 pi, I'm only having half of a cycle. So that means it's really drawn out. But again, like I did on that first one, I'm going to go ahead and figure out that the period is going to be this 2 pi over 1/2, or 2 pi times 2, which tells me that one cycle is going to be 4 pi in length, so really drawn out. So if I think back to my parent function for cosine, I'm going to start up at the max, so normally at 1, but for this it's going to be at 2. And then it normally crosses the x-axis, and then it's at the minimum, normally at pi, but since this is stretched, it's going to be halfway through our cycle, so it's going to be at the minimum at 2 pi, and then back to the max at 2. Kind of filling in the blanks here, we do go through the x-axis halfway in between our max and our min for the parent function. So that's going to be happening at pi and 3 pi. And then we can just kind of give our general shape for this. Make sure it kind of has some curve to it right there. There's kind of like an inflection at both of those x-axis points. For example 3, we don't have as much changing here. The only new thing we have is that we're adding 2. So if we're adding something to the outside, that just means that our midline is going to shift. So our midline here is going to be 2. How I would suggest drawing this is going ahead and putting in, it's not an asymptote, but just giving yourself a reference line there, that once I start drawing this sine function, it's going to go below that and above it the same distance. I don't have a different amplitude this time, so my amplitude is just 1, like the parent function. My frequency is normal, so I'm just going to be drawing in my sine from here, where I've got it starting at 0, and then it going up to 1, back to 0, below it 1, and then back to 0. So I guess instead of thinking about it going up to 1 and down to -1, you're thinking 1 above the midline, 1 below the midline. So that way our function hasn't changed in its shape, but it has shifted up 2. Okay, and then our last one, dealing with a horizontal shift. This can be a little bit tricky. Nothing else is changing here, so kind of isolated that horizontal shift. We kind of have to think about what cosine normally looks like, and then shifting each of those points over 1/2, pi over 2, sorry, to the right. So if normally cosine starts up at 1, for 0, if I shift that point pi over 2 to the right, that means it's at 1 here. Normally at pi over 2, it's at 0, so I'm shifting that one over. I'm shifting, my pi is normally here, so that's going to be 1 over. My 2 pi is now at 0, and then my, see, what would that be? 5 pi over 2 is at 1. So I've just shifted the whole thing. If it helps you to draw the parent function first, and then to shift everything pi over 2, that could be helpful. Remember, for all of these, we just drew in one cycle, but remember that they would keep going like that forever and ever.